let's explore quadratics in general, kind of what quadratics look like, how do I know it's a quadratic function, how would the graph look like before we start with our real quadratic lessons. Now these are things that you should know from grade 10. But again, because we haven't probably seen them for a long time, I'm not going to be able to remember it. So quadratic function is a polynomial equation that has an x squared in the equation and 2 is the highest exponent of x. That being said, any form, so let's say if you have something that looks like this, right? Or something that looks like this, or something that looks like this, okay? You see that there is one term that has an x squared in it, and that square is the highest exponent, right? That means this is a quadratic equation, okay? Once you have something that looks like this, for example, then right away we're going to say this is not a quadratic because your highest exponent is now at 3. Okay? So, for it to be quadratic, your highest exponent must be 2. You can have 1 term, 2 terms, or 3 terms. Are we okay with this? All right? Now, the standard form of a quadratic equation looks like this. Y equals ax squared plus bx plus c, where a, b, c can be a number, but the most important thing is a cannot equal to 0. Okay? B and c can equal to 0, but a cannot equal to 0. Okay? Because the minute a is 0, then I'm going to lose that ax squared term, and then it's going to become, what do we call this? What do we call this? What kind of function is this? That I only have x in it. Linear, right? Linear. Okay? So the minute I lose this term, then I'll have something that looks like this, which is, let's say, 5x plus 2, example, right? Then this is a linear function. Okay? So that's why I must have a value for a that's other than 0. It could be a decimal, could be a negative, could be a positive, could be a fraction, as long as it's not a 0. Okay? Are we okay with this? All right. Now, yes.
If value of a is 0, what happens?
If the value of a is 0, then you'll have a linear function, not a quadratic function. Okay? If Are we okay with this? All right. A quadratic function has the shape of a parabola. A parabola is a U shape or an N shape, if you want, graph. Okay? It can open up or it can open down. The U-shaped parabola, or the parabola, is symmetrical in every single way. Symmetrical means it has a shape. If I cut it in half, I don't know if you remember this from grade 1, when you say symmetrical, if you cut it in half and you fold it, it's going to equal each other, right? They're going to overlap. Okay? That's what a parabola is. It's symmetrical in every single way. We have many features of a parabola. We're going to be talking about them as we go. Actually, here they are. I'm gonna make this a little bit bigger so you can. So, I'm gonna start with the y-intercept. So the y-intercept is that point where your graph or your parabola is going to intersect the y-axis. We call it the y-intercept. Okay? We're going to learn about how to find that y-intercept because that's very important for us to draw. To graph that parabola, the y-intercept is going to help us. Okay? Then I'm going to move to the x-intercepts. The x-intercepts, they're the one where the graph intersects the x-axis. We can have two x-intercepts, one x-intercept, or no x-intercepts. And I'll show you something here. How many x-intercepts do you see here? Two. How many x-intercepts do you see here? One. Okay. How many x-intercepts do you see here? None. Right? Because it's opening down, it's below the x-axis, so it's not going to reach it. Right? Nothing's going to happen to the quadratic that's going to kind of like go everywhere. Okay? The direction's going.
So the one in the graph there that we're looking at is 2.
That's correct.
Because
That's correct. You see them right here. Right? So far we met the y-intercept, and you can only have one y-intercept, right? I mean, in all cases you're gonna have a y-intercept, but sometimes it's not visible, right? So sometimes, like if I drew something like this, you won't be able to see it from this, but if I keep going down, 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 it's gonna sometime intercept that y-intercept at a certain point. So, y-intercept, x-intercept. The third thing I'm going to talk about is the vertex. The vertex is a very special point. Okay? It's a point where your graph is going to either reach a minimum and then it's going to go turn back up, or it's going to reach a maximum and then it's going to turn back down. Okay? So at that turning point, we call that the vertex. Okay? It could be the point where you reach the high and then you go back down, or it could be the bottom of the hill. The vertex is a point. When I say a point, I need x and y values. Okay? When I write a point, I write it in terms of x, comma, y. Now, this point tells me two things. Tells me my axis of symmetry and tells me my optimal value. You're going to hear me say these words too many times. So the vertex tells you both of these. It tells you your axis of symmetry and it tells you the optimal value. What do you think the axis of symmetry is? It's the imaginary line that cuts your graph in half. You see that line that's going down here? That's called your axis of symmetry. It's that line that's going down here. That's your axis of symmetry. So that's a line that cuts your graph in half symmetrically. Okay? So if I actually take this and fold it on top of this, I'm going to get an overlap. The axis of symmetry is the x value of your vertex. We're going to talk about this. You're going to hear me say that over and over and over again. Okay? So knowing your vertex, you know what your axis of symmetry is. Okay? The y value value of the vertex, optimal value. What does the word optimal mean?
Maximum.
It could be a max, or it could be a min.
Maximum.
Maximum or minimum. It depends.
Oh.
In this case, it's a max or min.
Minimum.
Min. In this case, it's a
Maximum.
max. Right? So the optimal value could be either max or a min. It could be an either maximum or a minimum. It depends on if your graph opens up or if your graph opens down. Okay? And you guys can see, you see this sheet right here? So if your graph opens down, it's a max. If your graph opens up, it's a min. Okay? So all of these are the features. They're key features of a parabola. If I know them, I can graph the parabola with no issues. Okay? If I know my zeros, if I know my vertex, I know my y-intercept, boom. That's all what I need. Are we okay with this? Yes?
Go over the solutions, roots, and zeros again.
Yes. So the x-intercepts are also called solutions, roots, and zeros. So all of this, these three, they mean this. Okay? So if the question is asking you to solve for the solution, they're asking you to find the x-intercept. If the question is asking you to find the roots, it's asking you for the x-intercepts. If it's asking you for the zeros, it's asking you for the x-intercept. It's 4 different words that means the same thing. Okay? So these mean the same thing. Are we okay with that? Lots of fun. Okay, can I move to the next slide? Okay. So, as I told you earlier, that the vertex is your turning point, right? I told you it's either the top of your hill or the bottom of your what is it called? There's a name for it. There is a name for it. I forgot. Okay, so this is the vertex. It's your turning point. And the vertex is written as a point, as I explained to you, and it's written as HK, and I'll tell you why it's HK, which means it's the X value and the Y value. The HK is because later on we're going to learn this. Can I have your attention here for a second? So the quadratic has 3 different forms. It's not simple, unfortunately. Okay? The same equation can be written 3 different ways. It can be written in standard form, which we've already seen. It can also be written in vertex form, and it can be written in factored form. Okay? They use the H and K for the vertex form to represent the vertex. We're going to have a whole unit on this. Okay? So you guys don't need to worry about that right now. Okay? At this point. But you need to know that the X value represents your axis of symmetry. We already talked about that in the previous lesson. And we write it as X equals to whatever that value is. Okay? Again, I will re-explain the whole thing when we get to it. I just want you to understand the whole point and what's a quadratic. Okay? Did I skip a slide? I don't want you to worry about the domain and range because we don't certainly cover them in 3C. This would be more a 3M level. Okay? Here is the important part. when do my graphs open, or when do my parabola open up, and when does it open down? I'm going to teach you a trick. The A value is the one that makes it open up or down. Remember this A value that we said it cannot be 0? Remember that? Okay? That A value is in every single form. You will find it in every single form, and it's the same if you change it from one to the other. Okay? A. That A value, if it's negative, if A is negative, you see the negative starts with an N? Yeah? And what shape is N? Which way does it open?
Down.
Down. It opens down. So then your parabola will open down. Because negative starts with an N and N opens down. Okay? Is that a trick?
Yeah.
For you to remember?
Yes.
Right? If A is negative and opens down, then your graph is going to open down. If A is positive, then it's the other way around. There is no trick for it. Well, you're always positive, you're smiling, you're opening up. Okay? But remember the negative, and then the positive will kind of, it's the only other option.
See, in culture also B is there. That's okay.
Yeah, V opens up, that's right. But V is in both, that's why we can't use it.
Still is there. Our education.
But remember that N opens down, so it's negative. Are you guys okay with this? So it tells you here the parabola that opens upward has a minimum, right? It's on the board for you. And we don't need to worry about the rest because we don't do domain and range. And the parabola that opens down has a max. Okay? And then the A value is the one that determines if it opens up or opens down. Okay? Are we okay with this? Remember I told you that for the x-intercept there's 4 different ways that you can say x-intercept, solution, roots, and zeros. Okay? This is what it's referring to right now. So these solutions right, these x-intercepts, they are when y equals 0. Because if you're looking at this point, let's say this point is 2 right here.
Yeah.
Okay? This point is written as 2, 0. The y value is 0 for now. Okay?
And it's
And let's say this
it's
is
a positive,
1.
right?
Sorry?
It's a positive, right?
It's a positive. Yeah. And if this is 1, how would you write this point?
1 comes in.
1 comma 0. Okay? When we're looking at the x-intercept, the y value is 0 because it's touching the x-axis. Okay? This is what this is saying, and it's saying that they're all called roots, solutions, zeros, and I've explained that to you before. You can have 2 zeros, 1 0, or no zeros. Okay? I've already explained this to you. Are you guys okay with this? All right. Okay. Now, this is just an introduction to quadratics. Again, this is just a review from previous semesters or previous